All right, let's go second half of the test, all these word problems. You are building a multi-level deck. For each level, write a polynomial in standard form that represents the area of that level. Then write the polynomial in standard form that represents the total area of the deck. The biggest thing I want to point out here is this is level 1. There's no hiddenness to this. It's just level 1. And then this is just level 2. That's all we're at. So level 2 is the easier one because we have both the dimensions for, we'll write a polynomial for the area, right? So level 2, we go base times height, multiply it out, distributive property, whatever, x squared minus 12x. Now we go back to level 1. We got a little work to do before we can do any multiplication. We know that from here to here is x, but we need to figure out what from here to here is. And if you notice, it's this 10 and this x minus 12 will get us the full same side. So it's really x minus 12 plus 10, x minus 12 plus 10, which simplifies to x minus 2. So then we can go x times x minus 2, distributive property, x squared minus 2x. Since we're going for the total area of the deck, we need to take both of these, level 2 and level 1, and put them together and get like term, so 2x squared minus 12x minus 2x is minus 14x. So this is our total area of our deck. What is the total area of the deck when x equals 20? This says equals 20. So all we're doing, B, is taking the 2, plugging in a 20 in for x and solving. So I'm writing it out like that, and that's exactly how I'm going to type it in my calculator, parentheses and all. So 520 feet squared. We know it's feet because here's the feet label. We know it's squared because it's area. A gallon of deck sealant covers 400 square feet. How many gallons do you need? Well, so this is always 520 divided by 400 is 1.3. However, you're not going to be able to buy 0.3 of a gallon, so you probably need to answer this with 2 gallons. Okay. A hotel installs a new swimming pool and a new hot tub. Write a polynomial in standard form for the area that represents the area of the patio. So the patio is all the concrete poured that's not part of the hot tub, not part of the swimming pool. So it's an irregular shape. My base strategy is going to be to find the area of the whole rectangle and then subtract out the hot tub and subtract out the pool. That's how I think I'm going to do it. So to be able to find the area of the whole rectangle here, get rid of some of this. I need to know, I already know the full length. So the width, here's 2x, and then here's another 2x if I move it over, right? So for a total of 4x. So I'm going to go 4x times 8x minus 10 and get 32x squared minus 40x. So that's the whole rectangle. Then let's start doing the individuals. So the hot tub here is x times x, which is x squared. So I need to subtract out x squared. And then the pool here is 2x times 6x minus 14. So 12x squared minus 28x. And now notice how I'm going to put a subtraction and a parentheses around this 12x squared minus 28x, right? Because you got to subtract out the whole pool, and the only way you subtract out the whole pool is make sure you have a parentheses around that whole expression. So now I'm going to work to simplify this. 32x squared minus 40x minus x squared minus 12x squared plus 28x. From there, 32, negative 1, and negative 12, so 19x squared, I think. And then here and here is negative 12x. So this is our area of the whole patio, not including the pool and the hot tub. Patio will cost $10 per square foot. Determine the cost of the patio when x equals 9. All right, so there's two steps here. This is the area, right? But it's in polynomial form. So the first thing we want to do is use this x equals 9 to turn it into square foot form. And when we get that, we figure out that it's 1,431 square feet. Then from there, it costs $10 per, so we go 1,431 times our $10. We end up figuring out that to pour this whole thing is $14,310. Moving on. Okay, this one we actually did before in class. All you're doing is finding the volume of the container. So you're doing base times height times length, right? So the way this looks is something like this. Similar to part 1 video where we had to multiply 3 things together. I'd encourage you to take 2 of them, put them together. If you have to, use a Punnett square. Figure out that it's x squared plus 1x plus 2x plus 2, making it x squared plus 3x plus 2. Then you take this new thing and multiply it by this remaining thing. So this one I'm definitely using a Punnett square on because it keeps me organized. So make it a 2 by 3 box, 4x minus 3, x squared plus 3x plus 2. And from there, I'm going to go 4x cubed plus 12x squared plus 8x minus 3x squared minus 9x minus 6. And then I just got to pull it out and simplify. And this is the answer we're going for. That's the polynomial that represents the volume. Getting close. Okay. Sorry for that snot rocket. We did this one in class as well. The biggest thing to remember is this M is just a meters label. So I'm going to cross it out so you don't confuse it as a variable. You can see how that's done. But again, that meters just meant label. So write an expression that represents the area being paved. My strategy is going to be to find this box, and then I'll find this box and I'll add them together. All right, so 20 times x, the area in here is 20x. The big thing about finding the area in this top box is we're still missing a side here, right? And what we realized was that 18 minus this x will have our remaining side. So then we go x times 18 minus x, do a distributive property, 18x minus x squared. So this represents the area of this top box. Now for the total area of the whole thing in A, we need to take this and add it together. So 18x minus x squared plus 20x. Simplify it by turn this into negative x squared plus 38x. Now it says the area being solved. I really like this problem. The area being solved is 280 square meters. I like it because it's requiring you to do some different things. We set this polynomial, this expression that we wrote in part A, equal to 280 square meters, right? And now we're going to solve. You heard me say repeatedly in class that right now, as of the end of chapter 7, we have only one tool in our toolbox to solve this type of problem, and that's zero product property. So we got to get this thing equal to 0. Then we got to turn it into a product by factoring, and then we'll solve. I also don't like factoring when this thing's negative, so what I'm going to do is add x squared to both sides and then minus 38x from both sides and rewrite this thing as 0 equals x squared minus 38x plus 280. Then I can sit down and factor. Remember, x times x is x squared, and normally we just take the c term and we do things like 1 times 280, 2 times 140, 3 doesn't work, 4 probably works with 70, 4 and 70, 5 probably works, 5 and 56, so on and so forth. It ends up being 10 and 28 is the one we want because 10 times 28 is 280, and it also will equal 38. So 10 and 28. Then we just get our signs right. This parentheses implies x equals 10. This parentheses implies x equals 28. We also had a discussion in class why this one is extraneous and this is our only right solution. Because if we tried to call this 28 meters, then how is this itty bitty side longer than this big side? We know that can't happen, so it can't be 28 and has to be 10. All right, one last problem. A gift bag is like a rectangular prism, has a volume of 1,152 cubic inches. The dimensions of the gift bag in terms of its width are shown. The height is greater than the width. What are the dimensions of the bag? So if this is the volume, here's my plan of attack. I'm going to take this times this times this, right? And I know that that's expression, that polynomial is going to represent the volume. So I'm going to make this. And when I know that this is the volume, this expression, then I'm going to set it equal to this and see if I can solve backwards. Right? So I know I need to do this. So I'm going to do one of these. 18w minus w squared, 2w plus 4. 36w minus 2w cubed plus, what's 18 times 4, y'all? 72w minus 4w squared. So if we start to pull that out, negative 2w cubed minus 4w squared. Put these two things together. Oh, wait, that should be a w squared, right? W times w. So 36 minus 4 is 32w squared, and then plus 72w. Okay, now we take this whole expression, get rid of all this work, forget about it, right? Pardon that off. And we're going to set this expression equal to this 1152. Again, zero product property is the only tool in our tool bag to solve this thing. So we're going to get it equal to 0 and then try to factor it. Now you also got to pull on something you've heard me say multiple times. If there's ever 1, 2, 3, 4 terms in a factor, I'm only asking you to factor it in one way, and that's factor by grouping. So we pull out a negative 2w squared in this first one. We end up with w plus 16. If we then take, I imagine, a 72 out. So we take a negative 72 out. Is that right? Let me think. Yeah, problem with taking a negative 72 out. 14w squared, 18. Here's my problem. If I take a negative 72 out, then this is going to be negative w plus 16. So here's what I'm going back and trying to search for. I can't have these parentheses looking different. If I don't pull out a negative here, then this will be minus. What am I missing? W times 18 minus w, 2w plus 4. 18W minus W squared, 36W squared minus 2W cubed plus 72W minus 4W squared. Oh, crap. So this was a positive 36W squared, and this was a minus 4W squared. This should be plus 32W plus 32W. Okay. So from there, I can make this W minus 16. And if I pull out negative W minus 17 or 16, so then over here on this parentheses, I can just pull out a positive 72 and have W minus 16. And now we're on our way. So this comes out front. And then this is negative 2W squared plus 72. Interestingly enough, without fully backtracking, notice that this parentheses is both of these are even. So if I divide a negative 2 out of there and pull a negative 2 all the way out front, then this parentheses here becomes W squared minus 36, I think. And then we still have the W minus 16 right here. The reason I needed to do that is because I knew we couldn't solve this one yet, so we have to break it down farther. So coming up here, I have negative 2. This parentheses breaks down as the difference of two squares, W minus 6, W plus 6. And then we still have this parentheses, W minus 16. So now this parentheses implies 6. This implies negative 6. This implies 16. So now we can't have a negative with, so that's got to be an extraneous solution. Now we got to decide if that's 6 or 16. If we plug in 6 here and we plug in 6 here, then this becomes 12, and this becomes 2 times 6 is 12 plus 4 is 16. So that's got a chance. If we plug in 16 to each of these, the problem is this really skinny end becomes 16, and then this supposedly really tall side only becomes 2. We plug in this and it becomes 32, 36. So it doesn't really match the picture. So while I would probably accept this answer, I think this is the answer I'm going for. Winding back just to complete this video, notice it says, what are the dimensions of the gift bag? So as soon as we find this, we still got to go 6 by plug 6 in here, 12, plug 6 in here is 12 with 16. So we still got to finish with 16 by 6 by 12. Right? Okay, that ends part 2 of the review video. See if I can get out of here.